All right, we're going to go ahead and finish the notes that we started. So the next thing in the notes is to find the x-intercept and the y-intercept. So the x-intercept is where the graph crosses the x-axis. The y value is always 0, so the point is always written as x comma 0. The y-intercept is where the graph crosses the y-axis. The x is always 0, so the point is always written as 0 comma y. So they gave us a polynomial function to plug in and then asked us to find the x-intercepts and the y-intercept. And this really should have an S on the end. In fact, I'm going to have you guys add it to your notes. I'm going to put an S in parentheses because it's possible that it could just have one x-intercept, but these often have more. So if you look at this picture, it actually has 3 x-intercepts, and we're going to be finding all of them. So we're going to go ahead and go to the internet, and we're going to open up a Desmos web page in our browsers and go to the graphing calculator. We're going to type in this equation. So x to the third minus 4x squared plus 4. And remember, in Desmos, you can type the y equals or not type the y equals. Desmos is fine either way. So if I deleted that y equals, Desmos would keep the same graph. So it doesn't really matter. Okay, so the x-intercepts, I'm just going to go ahead and click on all 3 of those so that I have them, and then we can write them down. And I'm going to write them as points. So I'm getting the x-coordinate and the y-coordinate. So negative 0.903 comma 0, 1.194 comma 0, 3.709 comma 0. Right? And then I have the y-intercept up here, which is the 0.04. Okay, so let's go back and just make sure that we all have the same thing written down. So on the previous page, we had the increasing interval. It had 2 sets of parentheses. It had a U in between, which meant union. Now, even though we have 3 sets of parentheses for answers, we do not have to put the U. And the reason for that is because these are points. We've always written points without having a U in between. These are written as x comma y, x comma y, x comma y. So whenever you are writing points, you do not put the U. When you are writing something called an interval, you're writing x comma x, x comma x. And when you do that and you have to have both answers at the same time to be right, that's when you need the U. So if you're saying, where is the graph increasing, you need the whole answer to be considered right. If you're saying, what are the x-intercepts, you do need all the answers to be right, but you could say just one x-intercept at a time to be answering that question. What are some of the x-intercepts? Let me go ahead and give them to you. So that's the best way I can describe it, is that with these, you can just kind of say like, and it's one and the next, but the thing is, you don't even need an and sign. You can really just put spaces there. So now if you put a U in between on these, I'm not going to mark you down. I'm just going to scribble it out and tell you again that you don't need them here. Okay. Continuity just says whether the graph is a continuous curve. I think I meant to write where. I think that's a typo. Where the graph is a continuous curve, you can trace with your finger, or if there's a break of some sort. I think I just need to retype that sentence. It's awkward sounding. But if the graph is continuous, it means you can trace it with your finger without picking up your finger. There's no gaps in the curve at all. That's what it means for a graph to be continuous. And so there's a note down here. Continuity is going to be a boring question for these graphs because polynomial functions are always continuous. You can always trace them without picking up your finger. All right, last is the end behavior. We're going to be talking about the arrows of the graph. And so I'm going to remind you of something so that you don't forget. So that when we talk about the end behavior of the graph, we have two different directions we think of the arrows going. We think of the arrows going to the left and to the right. So if an arrow goes to the left, that's a negative infinity. And if the arrow goes to the right, that's a positive infinity. But we also think of arrows as going up and down. So if an arrow goes down, that's a negative infinity. If an arrow goes up, that's positive infinity. So whenever we describe an arrow, we always describe it using those two ways. We say maybe it could be left, but going up, and then it would have a negative component, but also a positive component because it's going to the left, but it's also going up. Or maybe that arrow is going to the right and going up, and then it's just completely positive. It's going to the right, but it's also going up. So whenever we describe the arrows, that's us talking about the end behavior of the graph. We're talking about the ends of the graph. So we always start off our end behavior by saying as x goes to negative infinity and as x goes to positive infinity. And so the reason that we do that is because we're saying, okay, look at the left side and look at the right side, because that helps us to look at the two ends of the graph. So look at the left side of the graph, look at the right side of the graph. And then you just have to say, oh, they're going up or they're going down. Now for this particular picture, both of these arrows are going down. So for this one, I'm going to say the left arrow, and then I'm going to say is going down. So I'm going to say y goes to negative infinity. The left arrow is going down. That's what this says. It's just saying it mathematically. And then over here, this one is saying the right arrow, and now I want to repeat, is going down. The left arrow is going down, the right arrow is going down. So that's all the end behavior is saying, is you are describing the arrows, but you are doing it mathematically, and you are doing it using infinities. So instead of saying left, you say negative infinity with an x. Instead of saying right, you say positive infinity with an x. Instead of saying down, you say negative infinity with a y. Instead of saying up, you say positive infinity with a y. And that's how I pointed to that, even though that says down. But that's how you describe your end behavior, is you describe your arrows, but in terms of infinities.